Lesson 5.1, Graphing Parabolas. In three different forms. We've got vertex, standard, and intercept form. So looking here, we have the three different forms. First one, we have vertex form. Okay. Now, as you can, just in the name of it, vertex form, this form is going to give us our vertex. Okay, that vertex will be given through h and k. Now, we've done absolute value functions. It's the same type of idea. Okay, h, k is that vertex, and you're always thinking opposite of what you see in the parentheses and what you're actually seeing with k. Now, when we're graphing these parabolas, the first goal is always to find that vertex. Okay, so find vertex. That is the big thing for any parabola, okay, no matter what form it is. Okay, so in vertex form, it's pretty easy to find h and k. Now, in standard form, it's a little bit harder. Okay, you get your coefficients with your x squared, your x, and then your constant. In order to find the vertex in this case, okay, you're going to find negative b over 2a. Okay, so you're going to use this, that b coefficient, negative b over 2 times that a coefficient. Now, that always gives us the x coordinate of the vertex. In order to find the y coordinate, you are going to take that negative b over 2a, whatever you get from that, and plug it back into the equation to find the y coordinate. Now, for intercept form, which is this one, it's a little bit tougher because what intercept form, it actually gives us the intercepts. Okay, so in order to find those intercepts, you're going to take both of those factors, because intercept form, it's just in factored form. So you take those factors, set them equal to 0, and then you solve for x. Okay, so those are going to give you your two x-intercepts on the x-axis. And then from there, since parabolas are symmetrical, you're going to find your axis of symmetry, and then that gives you the x-coordinate of the vertex, and then plugging it back in to the form, the intercept form, it'll give you the y coordinate. Okay, you'll see that here once we go through an example. But first one, we're going to go through vertex form. Okay, again, we said vertex is the thing that needs to come first. Find that. Okay, again, a, h, and k. Okay, so x minus 3, so 3. 2 is the vertex in this case, opposite of what we're seeing in the parentheses, what we actually see for k. So we have a vertex of 3, 2. Plotting that. Okay, now all parabolas that we're going to be doing are vertical, up and down, and then the axis of symmetry will always go through that vertex. And again, a vertical line is always x equals, so our axis of symmetry is, in this case, is x is equal to 3. That will always be the same as your x coordinate of your vertex. Now, the other thing when it comes to max and min, okay, that vertex is always the highest or lowest point. Okay, so it's all a matter of determining if it opens up or down. Okay, same idea as when we did absolute value functions. You look at that a value. In this case, it is negative. Therefore, this parabola will open down. Okay, so that vertex here, that is your highest point. Okay, meaning we are going to have a max. A maximum of y is equal to 2. Okay, we're just taking the y coordinate, and that is your max or min. Okay, then from there, we're going to get more points for our parabola. This is where that table is going to come in. Okay, we got x, f of x, a times f of x. Okay, now we've done this with the absolute value functions. Now we need to do it with parabolas. Okay, so the thing that changes is the type of function. Last time we did the absolute value. This time we are doing x squared. Okay, so we're going to do 1, 2. Okay, and again, that x column is going to tell us how far right and left we're going to go from the vertex. So 1 squared, when we go to the next column, is 1. 2 squared is 4. And then multiplying by that a value, which in this case is negative 2. So negative 2 times that middle column, the 1 and 4. So negative 2 times 1. And then negative 2 times 4, which gives us negative 2 and negative 8. So we can ignore the middle column from there. We're going to go right 1, down 2, from the vertex. Now again, we said this is a symmetrical, it's a parabola, so we're 1 away from the axis of symmetry, we can go 1 away there. So instead of going right 1 down 2, we can go left 1 down 2. Okay, so the next point, right 2 down 8. Okay, so we're 2 away from the axis of symmetry, so we're going 2 away on the other side. There is our parabola. Okay, so and then again, it's asking for the x-intercept. Okay, so x-intercepts, we're going to have 2 here. It crosses the x-axis twice at 2, 0, and 4, 0. Okay, y-intercept, okay, this is when x is 0. Okay, so to find the y-intercept, we would actually have to go in and plug 0 into x. So I'm going to work that on above. So y is equal to negative 2 times 0 minus 3 squared plus 2. So negative 2 times negative 3 squared plus 2, which is negative 2 times 9 plus 2, or 18 plus 2, to give us 20. Sorry, negative 18 plus 2, so negative 16. Okay, so our y-intercept in this case, 0, negative 16. That's not a point we're going to be able to plot. Not too worried about y-intercepts, but being able to find them again doesn't change from what we've done with lines. Plug in 0 for x, it gives you the y-coordinate for the y-intercept. Now, domain again, now that we have the graph plotted and everything, we can look at the graph and notice that how far left and right we're going. In this case, it's not going to stop going left or right ever. So again, our domain here is going to be x is the element of all reals. There's no x value we cannot plug in and get something back. Now for the range, we'll have a restricted domain because everything is below this point here. Okay, so again, below we're thinking less than or equal to, because we got to include that point, and range is always dealing with y. So y is less than or equal to that y coordinate of the vertex. So y is less than or equal to 2. All right, so that is vertex form. Let's move on. Let's do standard form. Okay, so in standard form, again, the vertex, we use negative b over 2a. That is going to be our x coordinate of the vertex. Okay, again, a, b, c. So negative b would be negative 12 over 2 times negative 2, negative 12 over negative 4, which will give us 3. Okay, so that's our x coordinate of the vertex. In order to find the y coordinate, then we're going to take that and plug it in. So negative 2 times 3 squared plus 12 times 3 minus 16. So negative 2 times 9 plus 36 minus 16, or negative 18 plus 36 minus 16, which in this case is 2. So again, we got the vertex of 3, 2, just by plugging our x coordinate into the equation. Okay, so now that we have the vertex, we can figure out the axis of symmetry. Okay, that's that vertical line that goes through the vertex. Okay, and again, is x equals 3. It's always going to be x equals that x coordinate. Okay. Again, we have a negative a value, so it's going to open down. Okay, so in this case, we will have a maximum. And our maximum is y is equal to that y coordinate, which is 2. Okay, so x-intercept, y-intercept, we'll worry about that after we plot our points. So setting up our table again, x, f of x, a times f of x. Okay, so before I just did 1 and 2. If it's going to help you, go ahead, do negative 2, negative 1, 1 and 2. Okay, before we just reflected the points over. If you don't like that method, go ahead and do those extra values in the x column. Okay, and again, our function here is x squared, so negative 2 squared is 4, negative 1 squared is 1, 1 squared is 1, 2 squared is 4. Multiplying by that a value again, which in this case was negative 2, so negative 8, negative 2, negative 2, negative 8. Ignoring that middle column, is saying left 2, down 8. Okay, left 1 down 2, right 1 down 2, right 2 down 8. Okay, so there is our parabola. Okay, so we have an x-intercept of 2, 0, and 4, 0. Okay, so again, those are those points where it crosses the x-axis, those 2 points there. Okay, y-intercept, again, we can't see it, so there we're going to have to plug in 0 in for x. Okay, so if we do that, y is equal to -2 times 0 squared plus 12 times 0 minus 16, which will equal 0 plus 0 minus 16, or 16, -16. So 0, -16. Looking at our graph, we see that it's going to go left and right forever. So the domain is x is an element of all reals, and a range y, and we're opening down, so less than or equal to that y coordinate of the vertex, which is 2. Okay, there is graphing a parabola in standard form. Okay, probably the hardest method of all of them is graphing when they are in intercept form. So when it's in intercept form, we can't exactly find the vertex right away. We can find our intercepts though, okay? Just by taking these 2 factors, x minus 4, x minus 2, and we're going to set those equal to 0, and then solve for x. So when we do that, we get x is equal to 4, x is equal to 2. So there's our x-intercepts, 2, 0, and 4, 0. So we got 2, 0, and 4, 0. Now, since this is symmetrical, we need to find the midpoint between those values, which will go through 3. So that gives us our axis of symmetry. And then we also know that the vertex always falls on that axis of symmetry, which gives us the x-coordinate. Okay, so then from there, plugging in that 3 into the equation, you get -2 times 3 minus 4 times 3 minus 2, which is -2 times -1 times 1, or just 2. So there we have our vertex of 3, 2. Okay, now we actually already have 2 of those points. We also know the axis of symmetry is 3. Okay, we also know it's opening down, so we have a maximum of y is equal to that y coordinate of the vertex. Okay, as for the y-intercept, plugging in 0 for x again. Okay, so plugging in 0, we're going to get -2 times 0 minus 4 times 0 minus 2, which is -2 times -4 times -2. Okay, 2 times 4 is 8. 8 times 2 is 16. We got 3 negatives, so it is equal to -16. So y-intercept of 0, -16. Okay, now we just need to find 2 more points. Okay, so doing our table. Again, using this table, this is just dealing with that a value, and this a value is still that -2. That a value is always that number that comes first in the equation. Okay, so -2, -1, 1, 2, squaring those values, 4, 1, 1, 4, and multiplying that column by that -2, -8, -2, -2, -8. Okay, so the points that we have already, there's that there, and those ones, left 1 down 2, right 1 down 2. Those were those 2 x-intercepts. So left 2 down 8, right 2 down 8, and there we get our other 2 points that we need. Okay, so now that we have the graph domain, it's going to go left and right forever. So x is the element of all reals, while the range, again, is opening down, so less than or equal to that y coordinate of the vertex, which is 2. Now, one thing that you should have noticed in all 3 graphs, it is the same exact equation. Okay, now it's just in different forms. Okay, we will learn how to go between those different forms Okay, like here we had, this was the vertex form. We can go to standard form by multiplying that out. Okay, multiplying it out, and if we can get into standard form, we can factor, and that will get us into the factored form. Okay, or we can use completing the square to get us to the vertex form. Many different ways of getting to the 3 different forms, which we will learn throughout the chapter. Okay. All right, so that is 5.1, graphing parabolas, quadratic functions. So we will do another video of just some more practice here for graphing. Your homework will be the 5.1 worksheet. Okay, so for now, just concentrate on that 1 through 12, and then this we'll talk a little bit about in the next video. Other than that, have a good day.